So let's take a look at RStudio, which is sort of part 2. So this is RStudio. And when you first open it, there's a really good chance that you won't have this part. You'll just see the console. So at this point right here, this is basically exactly what we just had in the previous R window. But you also get, in addition to that console window, there's sort of 4 parts. So this part up here is usually where you have a program or a document that you're working on. And I'll show you how we'll create that here in a minute. The top right window gives you information about your environment and your history. So like, obviously I've been doing a bunch of things. So it has all of my history here and other data that I've built. I'm actually going to come in here and clear my workspace, say yes. So when you first open it up, your environment's empty. So like as we create objects, it'll show us. So this is basically really nice. So I don't have to keep typing like ls and keep looking for my objects. As I create them, they'll show up over here. And then there's other things I can do once we get them created. And then down in the bottom right, it gives me information about basically like I can come in here and sort of, this is like a little miniature file explorer inside. Once I create graphics, it'll keep a running tally of all of my graphics windows, and I can page through those and say, oh, okay, here's version 1, here's version 2, which one do I want, which one do I like better. I'll talk a little bit about packages later on, but these are like all of the add-on functions. So base R comes with a lot of functionality, but then there's things that you may want to add as you go. The help menu, as we bring up help, this is all built in here, and I can't remember what viewer is. All right. Yes, so just to give you an example, like if I was here and say file, new file, so if I did an R script, so we'll try this as an R script. So one of the first commands that I had you guys run was get working directory. So I could be down here in my R console, and this is exactly like what I did before. So I type in the command, it comes back, tells me, which directory I'm in. But if I want to save all of those commands as I go, I could save them in a script file. And when you type in the commands up here, there's a little button here that says run. So if I'm on that line, I can click run, or I can highlight exactly the piece I want to do and click run. So this is like the equivalent of being in SAS with the little running man, or like if you're in SPSS in the syntax window, you can highlight what you want and click run. Very similar. So think of this as like your syntax or your program. And then if I want to change my directory, I'm going to come in here and type that in. So I'm just going to go back through this again. The other thing that's really nice is that when you're in RStudio, so both the this sort of scripting programming window and other things like that we'll do up here, it color codes stuff. So you'll notice that as soon as I put double quotations around the text, it changed the color because it knows, oh, okay, this is the text string that I'm using to find the directory. So it's kind of nice. And the other thing is if I leave off, it should come back. Usually if I leave off of parentheses, it'll come back and start giving me an error. I may just not have all that configured. So if I run that and then say, okay, but I want to, and I could type it again, or I can just run that command again to check it. And that's basically what I did here. So this is that whole script file that I've created. And then in R, anything after the pound sign is a comment. So this is the way to build in sort of comments and information. So this is the only command. Everything else that's there is just comments to the screen so that people can read it and see what I'm doing. All right. So same kind of thing. We've got math that we could do here. So I can type it in the console, but now that I've got it up here, I can just click run. So you get the idea. So you can go through and just sort of keep typing out these commands. Yes, so it's showing the results here on the bottom. So it's running them here. So this becomes like your programming window. This becomes the output window. All right. Same thing again. The constants are built in. So let's try that help menu that we did before. So this time, instead of opening in a browser window, it's going to show down here on the bottom. So when I do this, and I'm going to move this window around a little bit so you can see it. So now all my help, everything's like inside this RStudio development environment. And that's handy. If I'm inside here, so like if I wanted to, okay, I knew pi is a built-in constant, so I can actually search inside this document and find pi. But like, one of the other commands that we looked at was view. So there's two search windows. This little window here searches inside the current document. If I use this one, this searches all help everywhere else. So if I type that, then it'll go and bring up the help menu for view. Question? Nope. Okay. All right, so let me move this back. All right, so if we create the variables like we did before, so x is 3 times 5. Now when I click run, you'll notice up to this point, because we've just typed in things that was essentially math, the output here is coming actually just to the screen. It turns out there actually is a temporary variable that's getting created under the hood. I can't remember if it's called .first or .last, or .last value. Anyway, there's a way to retrieve it, but it's not shown because the global environment technically is empty because it's a temporary variable. It's like in cache memory. In theory, you can retrieve it, but if you really want to save something, that's why you have to assign it to an object. So we're going to create the object x when we run this little line of code. And now it shows up in my global environment. So now I have the ability, oh cool, so there's a number 15 and it's assigned to this value of x. I can still, just type it here if I want to see it on the console, but at that point it's not necessary. So what about y? If I make y and it's a sequence of values, and you'll notice this is interesting. Notice how it says int. So it's actually creating a series of integers from 1 to 12. So it gives me a little bit more information. It says, okay, this thing is of length 12. The stuff inside it are a bunch of integers. I could run it by itself. It'll print out to the console. Let's try it for Z where we made the sequence. You'll notice now it says this is length 21. So I'm generating 21 numbers. And these are numbers. This is called numeric. And there actually is a slight difference. This is something that's kind of interesting with R. It makes a distinction between an integer and a number. So this isn't in my notes, but I'll just show you this here real quick. So like y, the first value of y is 1, right? And then the 1 to the third value of z is also 1. Those should be equal, right? So if I say 2 equals, ask the question, is this equal to this? So that'll come back as true. But if I say y, that first value of y, is that equal to this third value of z? This is going to come back, oh, it came back as true. All right, well, there are times when this falls apart. Anyway, I've run into situations before because integers are sort of a special type of number. Anyway, so that worked. Should never do these things on the fly that I haven't tested out before, so just ignore that. All right. Anyway, that worked. But there are times when integers are very specifically defined. Okay. So I've got some information here. Again, this idea, I'd like to be able to see it. I can use this fix command or up here under, let's see, under view. Let's see, view, plot, edit. Yeah, we'll just run it. So if I run fix z, it'll come up and it looks just like it did in the regular R. I can also run view. I won't force the error again. We'll do the right one with uppercase V. So this gets a little odd. For some reason, vectors, when it opens, it gives me this little C command here. But here are the actual numbers. So like 0 is the first value, 0.5 is the next value, 1.0 is the next value. And when we start working with actual data frames, which is really how we'll actually look at most of our data, this is actually much easier to look at. I've noticed this, that sometimes looking at a vector by itself is a little confusing. All right, so same thing, we'll make the plot like we did before. If we make the sign of all of those values, again, it's a length 21. Here are those numbers. I can run the ls. I mean, it'll still, all of the commands that we had before still work, but to a certain extent, I don't have to do this because now I can see I have 4 values in my memory. Those are them. And I know this stuff is a little bit tedious to start with, but once you kind of get a handle on the environment, that was really the purpose of today, is just get your feet wet and play around with it. All right, so plot. We'll make a plot. So it pops up down here in the lower right. And I can also, so there's a couple of more things I could do here. So I can, if I click zoom, it'll open in a bigger window. I can make it bigger on the screen. I'm going to close out of this. There's export options here, so I can save this out as an image, as a PDF. I can copy it to the clipboard. We'll talk about publish later. There's actually some cool things here. If I click publish, I could actually publish this out on the web if I had a really cool graphic that I wanted to share with people. And let's add some more options like we had before. So I'm going to zoom this out. The other thing that's nice about the editor window, so this is a really long command, right? If I've got all of these options with subtitle, main title, Y label, X label, and so forth, I can actually, after each comma, if I hit return, the editor window is now designed to sort of try to make your code look pretty. Matter of fact, there's actually a package been written called Pretty R, that if you run that package on your code, it'll go through and fix everything. It'll fix the spacing, it'll give you hints on things to update, and so anyway. But that's kind of handy. This is something that's not easy to do when you're inside the console window, because if I hit return here, it gets a little confusing. But when you're in the scripting window, it's pretty easy to have things go on multiple lines. So the command actually starts here. And you'll notice if I highlight that, as soon as I'm touching the left parenthesis, the right parenthesis sort of gets highlighted. So it's showing me which parentheses are connected. So like this one, if I click there, it shows me, oh, okay, those two parentheses. So they should always show up in pairs. So if I run this set of commands, you just highlight all of them and click run. Now I've added, my title, the subtitle, my X and Y labels, and so forth. And in the base R package, it gets there's ways to add lines inside the plot command, but there are some handy things that, like if I just want to continue to add stuff to my current plot, there's actually a function called lines and another one called points. So suppose I wanted to come in here and add a blue line. I still have to tell it what X and Y are, but then I say, make the color of the line blue. And so color here is just COL. So if I run that, I add a line to the plot. Then I could go back and customize my points. So one way to do that is to use this points command. And tell you what, let me bring up the help menu on that so you guys can see what some of this stuff is. So if I look at this function for points, make it a little bit bigger. It says we're going to add points to the plot. You have to at least specify an X. It's useful to have Y in there to get all the coordinates. Then it has type, and then you'll notice it has these little ... So it says the ... dots here are further graphical parameters that could be added. And it says see details. So if I slide down here in details, here's some other things. So this PCH is a plotting character, and there's a bunch of these that you can see. The full set examples are below, so we'll keep going. Here's color. So there's different color names that you can put in. It has all the standards, sort of red, black, blue, green, yellow. But it turns out you can get really fancy. So if you know the hexadecimal color, the code for a specific color, you can type that in. So, and later on, I'm hoping I'll get to the point where I can show you guys some cool stuff in ggplot. There's now people that have done entire themes so that you can make your graphics look like something out of the Wall Street Journal. You know, it uses the same color scheme, it uses the same font family, you know. Again, people with way too much time on their hands. Okay. There's other things here, background color, characters, and so forth. So, sorry. Say again? I think so. So I think the graphics are better simply because you have a lot more control. So, and as they say, with great power comes great responsibility. So the good and the bad of this is you can specify and customize a lot of stuff, but out of the box, the defaults are probably kind of boring. So one of the nice things about SPSS and SAS, it usually sort of holds your hand and walks you through to get a halfway decent graphic. In R, you kind of have to specify a lot of that stuff, but you can really specify high resolution, publication quality. You know, if any of you guys ever submitted to a journal and they say we want the encapsulated postscript, getting that out of SPSS is a nightmare. So if you're ever having to do something, you really have to get something to that higher resolution. I usually use R, MATLAB, or SAS. So because SPSS needs to up their game, honestly, for graphics, for publishing at least. Yeah.
I have a more basic question.
Sure.
As we're beginning to learn RStudio and the basic R platform, and we're creating different projects, folder structures, and directories, what's a good naming convention to use? Should we use a new directory for a project or subdirectory? What your...
I try to have separate directories for a project. Now that said, I could have multiple R files or R scripts or programs or whatever, but maybe they're all connected to a single data set or a single project that maybe has multiple data sets. So trust me, different theories abound as to what the best approach is because it varies, I think, depending on the projects.
Especially if you're using multiple objects across multiple projects too.
Yeah, and in that case, sometimes I end up with multiple copies of things off my desktop. So, case in point, like I've got a project that I'm working on now that's actually combining data that's coming from the VA. And so the person that I'm working with, the VA, like I have a project folder for her, and then there's a project folder here for sort of part 2 of that data set where they worked with some people in the ADRC. So that data and those subjects are here. So I have them separate, but then I also have like a combined folder with all of the merged data. So that's a good question. And I am probably not the best organizer of data and files, but I usually try to have it where it's like I have things organized typically by PI or the person that I'm supporting, and then have projects under that. So like Sandy Dunbar, who I've been working with now like 8-9 years, I probably have 30 folders for all the different projects that I've worked on. So okay, so you know, we can go through and add more information to our plot. So we added lines. Here's the points function. In this case, I'm going to add a point using this plotting character 23, and I'm going to make it red, and the BG there just is going to say basically fill it in with a black color. So if I run that, now all of my I've overlaid these points, and that plotting character here, it's a little hard to see on the screen, is actually just a diamond, and it has a red border and a black. It's like filled in with black. So anyway, so there's lots of cool things that you can do. The neat thing about this is there's a book written by, I think it's Paul Merle. I could look it up real quick. that's a great book on everything and anything with our graphics. So this book right here by Paul Merle is a great book, and it explains all of the inner workings of R. So, pardon? I doubt it. I've bought it. That said, it wouldn't surprise me if there are pieces of his book that are out there floating around. Let's see what it is at Amazon. So the second edition at Amazon, it is in stock. The hardcover is $75. You can get it on Kindle. So, and if you're interested, I have a copy. It's at my house right now, but if you want to take a look at it, you can. The cool thing is that you can actually create objects. So suppose I wanted to create something like there's one exercise in the book where it has you go through and you're looking at temperatures across time, and the dot for representing the temperature of that day is actually this little graphic that you create that's a thermometer, and then the level of the mercury inside the thermometer represents the temperature, and then you use that. Anyway, you can do all kinds of cool things with it, to the point that you're like, this is too long. And then, like I said, we could go through and run these, or once it's all together, you just go through and highlight the whole thing and click run, and it does it all in one loop. And then this talks about the different formats and things that are out there. I think hold on, let me zoom in out here. So when this is open, I can open the image, save the image, copy the image. I can't remember what inspect does. And then in the export here, if you say save as image, it actually gives you some cool options. You can specify the width and the height. You can change the format. So it has JPEG, PNG, TIFF, bitmap, metafile. Support vector graphics, I think, is SVG. And then EPS is encapsulated PostScript. So like I was mentioning, if you ever have to have something and the journal really wants it in EPS format, it's a quick way to do it. And then you give it a file name and so forth. All right. Any questions? All right. We got just a couple more minutes. So let me show you a few things else that we could do that I hadn't had here. So we've got a couple of these values, right? We've got sine, x, y, z. Let's see. I had a couple more things I wanted to show you. Maybe I didn't save all that. All right, so we've pretty much done all of this. Okay, so I don't know why this didn't make it into my R script. So I'm going to cut and paste this stuff so you guys can see it. It's actually out here on the website. So I'm going to add these here. All right. So it turns out, up to this point, we've basically created things that were numbers, but you don't always have to have numbers. So there's different things that you can work with besides numbers. So I can create these different little vectors. So like this one would be a collection of numbers like we've done before. I could have things that were collections of letters or characters. And notice if I do that, this is length 6, and it tells me I have 6 characters. These are character type variables. You can also have logical vectors. So I can have it in R, you have to type true and false. You have to type the full word, and it has to be in all caps. So those are protected excuse me, words. But if I do that, now it says I've got this logic vector. And the really cool thing here is, so I'm gonna jump ahead here. So let's say A3. Okay. I'm gonna modify this slightly. So if I make this the same length, all right, so I'm gonna make this one, and that's of length 6. So it says true, false, true, true, false, true. So I've also got this other vector A2 of length 6. Guess what? I can kind of put these together. So if I said A2 and inside it use this, so what that's going to do is it's going to say, so like if I said, if I do this, that's going to come back and give me just that first value that's inside this vector A2. But if I use this thing that I just created, A3A, which is logical, it's going to come back and give me only the values for which that other vector was true. So this is really under the hood. This is how subsetting occurs. So you could imagine, right, that I could have something that says, go and find people that meet this criteria. And so this would store inside this vector a logical thing that says this person meets it, this person meets it, this person does not meet that criteria. So how many of you guys have ever done a data select statement inside SPSS? Right? So you go through. If you've ever looked back in your data file, right at the end of your data file, SPSS creates what's called a little filter variable, and it'll come back. That's how SPSS turns on or turns off which subjects or cases are selected. This is kind of how you do that in R. So if I have this logic vector and then use that to say, okay, go find everything in A2 for which this was true, then it'll come back and give me those values. And so this is some of more of what I'll kind of get into on Friday.
So is this used for like double-blind random like selection, like for identifying subjects for trials, or?
No, this is just more like manipulation and stuff. So like suppose I wanted to go through and do an analysis on a subset of people, or I'm wanting to section things out by other criteria. So this is one way to do that. And there's a lot of built-in functions that basically do this under the hood that you don't really see, but that's what it's doing. The other thing is, and this is important, and the reason I'm showing this to you guys sort of like in little pieces, eventually you're going to be doing this with a much bigger file, right? So what happens a lot of times when we import data, we get something from the lab, we get an Excel spreadsheet, we import the data, and everything comes in as strings or character variables. And you're like, that can't be right. Why is this coming as a string? Everything's a number. Well, it turns out, you get the cortisol measurements back, everything looks fine, and then somewhere down, stuck in the file, it says less than 0.2. You're like, so the computer doesn't understand the less than sign, right? It goes, oh, okay, there's a character in here, everything's a character. So in SPSS, I got too many software packages. In R, we can mix and match things and watch what happens. So in this case, I'm trying to say, okay, my first two values are numbers, 1 and 2. My next two values are letters, A and B. My last two values are true and false, which are logical. When I run those together, what it does is it tries to figure out the best mode or the best type of data to store everything. So I'm not losing anything. And so when it creates A4, everything becomes a character. So now it's not the number 1, it's the character 1. And then like here for true, it's that string of letters that spells it TRUE. But other things you can mix and match. Watch what happens if I mix numbers and logical. So now I get 1, 2, 3, 4. And what are the last two numbers? 1 and 0. So it turns out that one nice thing about logical values is that if somebody's given you something where somebody's gone through on I think there might be a way to do this in REDCap, but if somebody clicks the checkbox to mean yes, so it's like an indicator variable, basically they're saying, yes, this is true for me. So a lot of times this is candy because you can convert trues and falses to ones and zeros really fast. And so R does that for you here on the fly. So if we're looking at A5, the last two numbers get converted to ones and zeros. So just be aware of that, because when we start bringing in data sets, sometimes some of this stuff will happen on the fly and you're like, this looks different than it did in Excel. So, question?
It just does it because it doesn't have any characters in its strings.
Right. Yeah. So the nice thing about trues and falses, even though technically if you just have nothing but that, it'll recognize it as logic. But I can actually, there's ways to convert this to numeric and say do a sum. So like say you had a whole bunch of truths and you wanted, okay, well how many people, what was the percentage of people for whom this was true? So there's ways to do that, and basically all you're doing is converting ones, calculating a sum against the total, it calculates the percentage, that kind of thing.